Today we are doing a medium problem 1. Find entry count unhappy friends. You are given a list of preferences for n friends where n is always even for each person I. Preferences I called the list of friends sorted in order of preference. In other words, a friend earlier in the list is more preferred than a friend later in the list. Friends in each list are identified by integer 0 to minus 1. All friends are divided into pairs. The pairings given is blah blah blah. Unhappy. If X is paired with Y and there exists a friend U who is paired with V, but X prefers U over Y and U prefers X over V, return number of unhappy friends. What the hell? Hell no. Okay. I mean, that sounds like a dogshit formulation for something easy. So basically, I pick pairs. I mean, they say XY, right? But what if I pick XU, right? And then what I want to count? I pick XU and then friend X is unhappy if he is paired with someone and the other guy is paired with V. So if I pick V, that means that I locate U in X's list, and the point is we are unhappy if how many pairs is there? Oh, just half. Okay. Okay, so the problem is, let's say I pick like U and X from two lists, and if there is something in both lists later, why such a dog shit, bro? Oh my god, man. I mean, if there is a half pairs, then let's say I pick a pair. Can do cubed solution, so wait, this might not be that slow, because so I pick two of these, right? and then so I pick two of these arrays, and then we locate the other one. So let's say we picked 0 and 1. So 0 is here and 1 is here, and then we want to count suffix from here, what's in here. That sucks. But wait, don't I just have to go through those suffixes, because each of these lists is of length n, and what? I just go over it? Are you kidding? You kidding, bruv? Const x u in pairs so I go through it. If x is paired with y and there exists a friend u who is paired with this, wait, so no, that's not that simple. So I have a y from here, like one of these guys, right? And then for each of these numbers, right, let's say my friend is 2, right? So I pair 1, 2, and for each of these guys I have to test if they don't prefer so I just look at what 3 is paired with and where is 0 in there, and that's it, and check if it's not swapped. Okay, so for each pair x, y, do this, check all numbers, check all people u, preferred, then y, for each person u, check their pairing v, and finally check if x is less than v in preferences u. Okay, so paired with, so okay, so after we have done these pairs, let's just see if this even runs. Yeah, you cannot really do this because who puts pairs like a vector? Const auto pair yp1. Okay, this should work. And then vector int lots location of preferences I j is j, that's fair. And then after we have done then we go for const auto p pairs p0 y p1. And now okay, so for int j jn minus 1j plus and preferences x j don't equal y, then we do this. So I prefer you more xj, and then if location u of x smaller than location u of paired with u, well, that means that's unhappy, so this should be more. So this means that he's unhappy. Lots preferences ij. Oh. Okay. Let's do this. Auto check. Function void int check int x int y check p0 p1 p1 p0 1 is paired with 0. So 1 is paired with 0. And location at x of int v paired with u xv over location xy, like this. X prefers u over y and u prefers x over v. So this is u, v is what you are paired with, and u prefers x over v, and x prefers u over y. I mean, we have that, so I don't have to put this in. So I'm not sure, like, what? So is 0 friends 1 and 2? Okay, so 3 is unhappy. So this guy is unhappy. Three is paired with 2, but prefers 1 over 2. Okay, so that's here, and then and 1 is paired with 0, but prefers x over 0. So let's so x is 3. Pair this with y. U is 1 and v is 0. So location of u of x, which is 3, is... No, wait, what? Like this? Okay, so I was returning number of happy friends. Okay. I mean, that's absolutely stupid ass problem, bro. I mean, okay, this is stupidest medium problem. Terrible problem statement, easy solution. O(n) squared. For each pair, this problem statement is written very poorly, but the solution is very simple. For each person, we store with which person it's paired with in paired with array. Next, we store for each person's order in for each person I, each person j's order in person y's preferences. Now to solve the problem, we first go over all person u which are more preferred by x than y. Now to solve the problem, we check each pair xy. We first go over all persons u which are more preferred by x than y, and we simply check stored in location ij. Check if location of their pair person is paired with u equals v, and simply check if location of ux is over location of uv, which is exactly what the problem statement is asking for. Time complexity O of n squared, since we first build the paired with array in on, then build location to the matrix in O of n squared by iterating over all preferences, and finally for each of the on pairs we do this whole check for y2. And then do this check for each of the n pairs. We check at most on persons u more preferred than y of n squared, since the location matrix takes up memory. okay. I mean, most dog water solution like problem of all time, but you know, you usually get these kinds of painful problems to see if you can even code in interviews, so why not? Goodbye.